Okay, so we answered some questions on the dosages based on weight. The next section is very similar to that. It's dosages based on body surface area. And one of the ways we can calculate body surface area is to use something called a nomogram. And these used to get used in medical fields a lot. Now, with the invention of computers, there are a lot of computer programs out there. You can just plug the numbers into the little applet and it'll spit out what the result is. But a nomogram is nothing more than a graphical way of determining things. And I'm going to put the nomogram is in your textbook. It actually appears twice. Once on page 192 and then again on page 193. And well, let's just do this. For example, let's say that we have a patient. So we have a child who is 88 pounds and 44 inches tall. So 88 pounds and 44 inches. Here is our nomogram. So what I'm going to do, I ain't going here. We said 88 pounds. Over here, pounds. This is the side that says pounds. This is their weight. I have to find 88. Now, of course, this is going to be approximate because it's 80, 85, 90. 88 is going to be somewhere in there, slightly closer to the 90. 44 inches tall. Is that what I said, really? Okay, kind of a chunky little guy, but okay. 44 inches tall is going to be right about there. This is the inches side over here, so this is the 44 inches. Poor kid. So anyway, we're going to now connect those dots. So I'm going to start here. Oops, that didn't work. Well, I guess it did. It just wasn't going to tell me it worked. And connect it over to here to where about the 88 would be, somewhere in there. And I'm going to change the color of that line. Maybe not quite that big. Okay, so everybody see that red line? Is that big enough you guys can see it? Okay. So you can see that red line goes from the 44 inches over here, maybe adjust it just a hair, if it'll let me, there, to the 88 pounds over here. This scale right here, if I can get to it, is the body surface area in square meters. Body surface area is always calculated in square meters, no matter whether we're given pounds and inches or kilograms and centimeters. So this we can see is going through between 1.1 and 1.2. So that'd be 1.1, and there's 5 divisions, so each of those is 200. So 1.12, 1.14, 1.16 square meters is what that appears to be about. Now I can see that you can see it's very cluttered and it is tough to read in there, especially the higher up you get here, the closer the marks are together. So you are kind of taking a guess. I mean, if you said 1.17 or 1.18, it would be hard to argue with you because of the way how tight those lines are together. So you can see it is somewhat approximate. Let's say we have another patient. This patient is, let's say 45 kilograms and 145 centimeters tall. So 45 and 145. So back to here. We have to find both of those. So 45 centimeters is going to be right here. 145 kilograms is right there. 145 centimeters is somewhere in here. So let's just take this line and move it. Okay, that's pretty close to lining up. Maybe just move it slightly over here. Now, generally what I would do is just take the edge of a paper or something like that to line these up. My electronic lines may be more trouble than it's worth here. But okay, see, that's pretty close to being lined up on 145 centimeters over here for the height and 45 kilograms over here. And it looks like in the middle here it goes through almost exactly at 1.4 square meters. So back to here. This one came out to be about 1.16 to 1.18. This one came out to be about 1.4. Another part of the nomogram, you could say, okay, a child who is HWP, what does that mean? Height to weight proportional, yes. Or normal weight for height, or however you want to describe it. And is 40 pounds. So there's this section here for children who are of normal height for their weight. We have pounds and kilograms again. This is, actually we don't just have pounds on this one, sorry. So here's 40 pounds. We would trace that over. That is between 0.7 and 0.8. Looks like it's almost exactly at 0.75. Do you see where that one works? That's just this one here. So we're only using their weight and not their height, assuming that they're of normal height.
Are they talking like 50 percentile? Or?
You know, I'm not sure what range they're actually talking there. That's a very good question. I'm assuming there's got to be a little bit of a range, like anywhere from like 35th to 65th or something like that. Normally, they usually talk about one standard deviation in a lot of cases, and one standard deviation generally contains like 68% of the population. So that would actually go from like the 16th percentile up to the 84th percentile in a lot of cases. So that range is generally bigger than what you would think.
Yeah.
It would not shock me to at least see it 20th to 80th,
Okay.
or 25th to 75th at the least. But anyway, this last one, of course, we only gave you the weight, so the only thing we can do is use the nomogram for that one. And as I mentioned, there are a lot of computer applets out there where you just pull up that program and type in the height and weight, and it'll spit out body surface area in square meters. But let's say we don't have the nomogram, or if you're like me, I don't like the nomogram very much. Maybe because I'm a numbers cruncher. And we have formulas. If we are given the height in inches and the weight in pounds, the body surface area in meters squared is equal to the square root of their height times their weight divided by 3,131. So we had two patients up here. We had one that was 88 pounds and 44 inches. Let's see what that one comes out to be. This will be 44 inches times 88 pounds divided by 3,131. And then square root it. So on my calculator, I can enter this all at once. I do second square root. Oops, that's not one. Second square root. And I don't even need parentheses because this is actually just multiply then divide. I can just do 44 times 88 divided by 3,131. Now I get 1.112 square meters. The nomogram gave us, remember, 1.16, 1.17, somewhere in there. To The question is, which is more accurate, the nomogram or the formula? Answer is really, who knows? I like the formula better because, like I said, I feel reassured that I just crunched some numbers and I got an answer. So, another weakness of the nomogram, by the way, the height, if you notice, goes up to 90 inches. Now, in your careers in medicine, I'm guessing you're probably not going to encounter too many people that are 7'6". Not in Wisconsin. But on the other side, the weight only goes up to 180 pounds. And I'm guessing you're going to encounter a whole lot more people that are over 180 pounds. So the nomogram has limitations. Obviously, the height isn't a problem because it does go up way more than you'll ever see for height. But you are going to encounter a lot of patients. So this nomogram really is only good for children, pretty much. You know, people that are, I know there's a lot of adults that are under 180 pounds, but there's a lot that are over. So for adults, pretty much the formula has to be used for their body surface area. So let's say that we have an adult patient who comes in with a height that is 6'2" and 230 pounds. How am I going to find their body surface area? Obviously, their 230 pounds is outside the range of the nomogram. Well, first thing I got to deal with is 6'2". The formula requires their height to be in inches. So how do I convert 6'2" into inches? Perfect. 12 inches per foot means I take that 6 feet times 12 is 72. Then I add those other 2 inches to it to get 74 inches of height. Perfect. So now my body surface area will be the square root of 74 times 230 divided by 3131. Second. Square root?
Yeah.
You've got a cell phone here. Let me come over and take a peek quick.
Yeah, I don't have that. I
A
have
lot
some
of
square roots,
the
but they're
cell
all
phones, if you flip it sideways, you've got like square root.
Is it the 2, 3, or the?
Okay, you've got the 2 with the root X on there.
Yeah.
That's the one you want.
I tried that and I didn't get it.
But for you, you've got to do the numbers first.
And then push it.
So like you have to put like 25 in there and then press that key and it'll square root it. So for you, you would have to do for this problem 74 times 230 divided by 3131. Hit equals and then press that key. And yours looks to be exactly the same.
So is that what the system?
That looks about right. Hopefully that's what we come up with. Does anybody else have a different calculator that they're having a hard time finding?
Mine shows up right away.
Yours shows up right away.
So it's 2.33?
Let's take a look.
I might have pressed it twice.
Okay, you might have hit that. That would have done it too if you pressed it twice. So mine, I get the square root in first. So 7. Yep, you have to hit equals before you do the square root on yours. So 74 times 230.
Oh, yeah, I got 2.3.
Okay, divided by 3131. And I also get 2.33. So let's try one on our own. We have a patient who comes in at 5'11", weighing 195 pounds. Find the body surface area.
Can you just test us on this?
I'm just this. Put in a bidding process where you can just, put in bids for questions you want to see. You guys submit your own questions along with a check.
Okay,
And the ones with the largest check, those will be the questions I put on the test.
This is worth money to me.
It's not that bad. You'll do just fine. So how many inches tall is this patient? 71. Very good. 5 times 12 is 60. Plus 11 is 71. So 71 times 195 over 3131. I forgot to hit the square root, but I can put that in there now. So 2.10. Perfect. Meters squared. So that's if their height is given in inches and their weight in pounds. Well, more and more now they've got the scales programmed as you come in to weigh in kilograms. So if you have a height in centimeters and weight, and obviously weight is not, kilograms is not really weight, it's mass, but we say weight in kilograms. The formula to find the body surface area, again giving us the result in square meters, excuse me, is the height times the weight divided by 3,600. A lot of people are kind of amazed by this because they would expect that number on bottom to change by a lot more, because a centimeter is a lot smaller than an inch. But a kilogram is also quite a bit bigger than a pound, and the difference between them actually almost balances out. So anyway, let's say that we have a patient. Well, let's go back to use our example we did up here on the nomogram. This patient was 45 kilograms, 145 centimeters. We got 1.4. So let's try this out. 45 times 145 over 3,600. Second square root, 45 times 145 divided by 3,600. 1.35. We had 1.4 square meters from the nomogram. So as you can see, consistently the nomogram gives us a slightly larger number than the formula. I have looked and tried to check to see if the formula is approximate and if there's problems with it. And if the nomogram has just been adjusted to be more accurate, or if it's the other way around, that the formula is accurate and the nomogram is just off, I cannot find an answer to which one is more accurate. So maybe once you guys advance on to wherever you use this next, hopefully somebody there can tell you which way is more preferred. Like I said, there now are several programs out there. You just punch them in. So I'm going to have you guys try this. The recommendation. Now, generally, body surface area calculations will be used for a couple of things. Burn victims is the big one. Second, any sort of skin condition like a rash or an outbreak, poison ivy, stuff like that. So let's say our recommendation is 0.8 milligrams per square meter per day. For a patient who is 160 centimeters and 90 kilograms, find the recommended dose. Well, first thing we need to find is the body surface area of this patient. So I've got height times weight, so 160 times 90. Are we going to divide by 3131 or 3600? 3600, because these are in metric. So we've got second square root 160 times 90 divided by 3600. I'm getting exactly 2 meters squared. Is that what you guys get? I couldn't have planned that out better if I tried. So anyway, We get 2 square meters. So that means the dosage for this patient is 0.8 milligrams per 1 square meter. We're going to do milligrams per the 2 square meters of the patient. We will cross multiply and divide. So it'll give us 1.6 milligrams for that patient. You may have learned by now that we always make it worse. There's always another step. So let's say the recommendation is, bless you, 1.2 milligrams per square meter per day. The label says 2 milligrams per 25 milliliters. Our patient is 5'3" and 140 pounds. So again, find the recommended dose. Well, again, first step, body surface area. Square root of, what's going to go in for our height? 63 inches. 5'3" is 63 inches. 5 times 12 is 60, plus 3 is 63. Times 140, over this one is 3131. So second square root, 63 times 140 divided by 3131. 1.68 square meters. Next, that's 1.2 milligrams per square meter per day. So 1.2 milligrams per 1 square meter equals how much? How many milligrams for our 1.68 square meters? So 1.2 times 1.68 divided by 1. Gives us 2.016 milligrams. That was what I was just going to say. In your program, they may ask you to round to a certain number. I mean, body surface area is almost always rounded to 2 decimal places like that. Milligrams, I would most likely be tempted to round that as 2.02. Again, I'll leave the discussion of rounding up to your program. Like I mentioned with the drop rate, the drops for infusing. We'll leave drops to 2 decimal places for now, even though you're going to round them later. This one, either way, it would be fine on a test.
Okay, I have a question.
Yeah.
Why is the label on there? We didn't do anything with it.
Haven't done anything with it yet.
Okay.
But our next step is, how much are we going to give to this patient? Well, we have to put that into milliliters. 2 milligrams for 25 milliliters. So we're in milligrams. Our 2 milligrams will go on bottom. 25 milliliters on top. So now, milligrams cancel. We take our 2.016 times 25, gives us 50.4 milliliters, over 1 times 2 is 2. That divides out to give us 25.2 milliliters per day. So let's say we got a recommendation of 4 milligrams to 5 milligrams per meter squared per day. Label states 2 milligrams in 150 milliliters. Drop factor of 20 drops per milliliter. Patient is 175 centimeters and 80 kilograms. I want to know, find the drops per minute for this patient. Okay, well, this ought to be fun. We're going to start out with finding the body surface area again. This might be a step beyond what I would expect you to be able to do on a test, just so you know, so you don't panic. Each one of these steps individually I would expect you to be able to do, but I probably wouldn't put all 5 or 6 steps together at once. So we have 175 times 80 over, what's going underneath this one? 3,600, very good. So square root 175 times 80 divided by 3,600. 1.97 meters squared. And this is a titration. We've got 4 to 5, so you want to use the 4 or the 5? 5, okay. 5 milligrams per 1 meter squared. 4 it is. No, just kidding. I see. So anyway, 5 milligrams times 1.97 square meters divided by 1 square meter. So just 5 times 1.97. Gives us 9.85 milligrams. Now, of course, that's going to have to be converted. Put that over 1, and we're going to multiply it by, what do we have? 2 milligrams per 150 milliliters. So the milligrams cancel out. We've got 9.85 times 150. Then we're going to have to divide that by the 2. Because it's 738.75. That is milliliters per day. Everybody follow that? 738.75 milliliters per day. So let's keep going with this. Let's get it to the drops per minute. But 738.5 milliliters per 1 day. We first have to get rid of the days. So 1 day is 24 hours. And I'm going to keep going with that. I need to get it to minutes anyway. 1 hour is 60 minutes. So the days cancel, the hours cancel. This is going to put us into minutes. So what we have here, 738.75 times 1 times 1 is 738.75 milliliters still. Over 1 times 24 times 60 is what? Is that 1,440 minutes? 1,440 minutes. So we're going to divide that 738.75 by 1,440. Gives us 0.513 milliliters per minute. We're not done yet, though. So 0.513 milliliters over 1 minute. We need to bring in our drop factor, which was 20 drops per milliliter. So 0.513 times 20, 10.26 drops per minute. Now, of course, that is the maximum because we use the big number. How do we find the minimum? We'll take our 10.26. I'm going to drop the units just to expedite this. This was the maximum, so we're going to use the big number, which was 5 on bottom, little number, which is 4 on top. So 10.26 times 4 divided by 5 should give us 8.21 drops per minute is our minimum. So our acceptable range is anywhere from 8.21 drops per minute to 10.26 drops per minute. What do you think? Like I said, don't get scared. That one's a step beyond what I'd make you do on your own ever. So we have about 15 minutes. Let's take a quick look back through everything that we need to be ready for next week. Tell you what, I'm going to end this recording here.